what is the right way to work with EF Core transactions? This topic can be a little confusing if you are new to EF Core, and I've even seen some more senior developers make mistakes when it comes to using transactions. So I'm making this video to clear up the misconceptions and show you what is the correct approach to using EF Core transactions. Here's what I'm going to use for the example. I've got a minimal API endpoint that's accepting a company ID to be able to fetch that from the database and then perform some updates on the company and the employees table in our database. The database context itself doesn't contain the database sets. We can get those with the set method anyway. It wouldn't really change anything, and it just describes the structure of the employees and companies table with some seed data that's populated when I run a database migration. I'm using Postgres as a database, and everything's wired up using Aspire behind the scenes, which is going to spin up and create my database instance, and I can just connect to it by passing in a connection string. So what's going on in the increase salaries endpoint? We've got a very simple example of fetching an entity from our database. So I'm using db context set, specifying company to denote which database set I'm working with. Then we're going to include our employees and do a filter by the company ID. If this is null, we return 404 not found. We iterate through the employees, which we included in the statement above. So this is also not efficient from a performance perspective, but bear with me, we're also going to fix this. So as we iterate through the employees, we increase your salary by 10%. We set the last salary update date, and then this is the key part. We persist everything when calling SaveChanges. So how EF Core works is when you load an entity into memory, it adds it to the change tracker. This keeps track of what is the current state of the entity, and as soon as you make some update, like changing a property value, that entity gets flagged as modified, or when you insert or remove entities, they are marked as added or deleted. And finally, when calling SaveChanges, EF calculates what is the difference from the initial state to the current state, and it figures out which SQL commands to execute to apply the necessary changes on your relational database. So this is just an intro, and our core topic is going to be about transactions. And we have to first understand how EF Core uses an implicit transaction, which is there whenever you call SaveChanges once and you've only made changes using the change tracker before that. So when we call SaveChanges here, EF is going to send a request to our database, and this will be implicitly ran in a transaction, meaning that the updates that we have here are going to be either all applied at once or they won't be applied at all. So to show you how this works, let's set a breakpoint here, let's run the app, and I'm going to send a pull request to our API with a company ID of 1. So when I execute this, we're going to hit the breakpoint in our minimal API where we're going to fetch the company. Now I have 1,000 employees here, so I'm not going to iterate over them one by one. Instead, I'm going to just jump over these, and we're going to call SaveChanges here. Now, how do we know that our changes have been persisted? Well, we can look at the output window here, and here you can see our update statement to the employees table, as well as the respective update on the company table. Now, because this is pretty small, I'm going to switch to the Aspire window, where we can see a distributed trace, and we're interested in the updates. So here's the update for the companies, and it's also updating the employees. And then we have another statement here, which is another update statement sent to our database. And this is because of how EF batches these commands, and it may issue multiple requests even though you're calling SaveChanges once. So this all runs in a so-called implicit transaction. Now let's look at another example that's a bit more performant. So I'm going to call this increase salaries SQL. And instead of including the employees when we fetch the company from the database, we're going to update this using SQL. So how can we do this? You can access the database context, which exposes a database facade. And here you can say execute SQL. So I can do something like say update, and I'll specify the employees table. And we want to set the salary for each employee to be the current salary multiplied by 1.1. And we want to filter this to say that the company ID for each employee should be the company ID value. Now let me move this into its own row so that we can see the entire statement. And don't worry, this isn't SQL injection. Firstly, because we have an integer here, so that already protects us. And secondly, this string will not be interpolated. Instead, it will be turned into a parameter and sent as a parameterized query to the database. So everything's good, but let's execute this version without a transaction first. So I'll send a request from my command window, and we're going to hit the breakpoint in our new endpoint. Now you may notice that I slightly immediately change the query. I just had to add quotes around the table name and the column names because I forgot I was using Postgres and it has a different naming convention by default. So we're still going to fetch the company, but this time without the employees. So the quick log here shows just a single select, and then we're going to do our update. Now notice that this is immediately executed on the database. We didn't call SaveChanges, and yet this was still applied on our database, which means this is part of its own transaction when you think about it. The transaction itself is implicit, but if this call to SaveChanges were to fail, our update to the company, which is triggered with this line of code here, would not be persisted, while the changes to the employees would still be applied to our database. And herein lies the problem. Now, the reasons for this call failing don't have to be just a database failure. You could have some other code here that, for example, calls out to an external service or does some other work, and this causes an exception which breaks your implicit EF transaction, but this was still applied to the database. So now you're in some in-between state that you don't really want to be in. And I've seen this happen so many times, and it honestly frustrates me. Now, luckily, the solution is simple. All you have to do is say db-context database begin transaction. You can also use the async overload, it doesn't really matter, and you just define this inside of a using statement. So now everything that we run below is part of the transaction, but nothing gets persisted until we say commit or commit async. So if I wanted to move everything into the async methods, I'd have to update to await using here, and of course I have to await this call, and this time we don't get anything executed until we commit the changes. So let's run this demo. I'll send another request from my CLI, and then let's walk through the steps here. So we're executing the update. Now you can see it in the log because it is sent to the database, but it isn't physically persisted until we commit the transaction, which happens now. So either this all completes successfully and we call commit, or something in between here fails and the transaction doesn't commit, and any potential changes get rolled back. The problem with using SQL, like I'm doing it here, is that we don't get type safety. So I'll show you another example that uses the bulk update support that we have in EF Core. And how you do this is you select the entities you want to update, in this case the employees, where the company ID is equal to the company ID that we are updating. And then you say execute update or delete. Now there's also async overloads. So if we await this, we can also execute this. And what we have to do here is define an action for how we're going to set a specific property. So first we have to define which property we are updating, and that's the salary. Then we have to define another delegate, configuring how we're going to apply this update. So we're doing the same thing, just in a different way. And that's something that I find really cool about C# is that you can do the same thing in multiple different ways, but it also annoys a bunch of other people. So depending on if you're a glass half full or glass half empty type of person, this may or may not be a benefit. The reason I'm showing you this example is because ExecuteUpdate and also the ExecuteDelete bulk method do not run as part of the implicit EF Core transaction. So whenever you use this in conjunction with SaveChanges, make sure to wrap everything in an explicit transaction. And I want to show you one more example, which is going to be similar to the first one. So I'll actually copy the first endpoint here, where I do want to include the employees. So I'll drop it here, and let's call this multiple SaveChanges for lack of a better name. And what I want to do here is something like this. Let's say after iterating all of the employees, we call SaveChanges, then we update the company, and then we call SaveChanges. And again, this is a contrived example, but I've seen countless examples in production code bases where you've got a big chunk of code, let's say a method with 50 to 100 lines of code doing some logic, calling SaveChanges, then returning control back to another method that was calling that one, and this method also does some work and calls SaveChanges, and you may not even be aware that you are calling SaveChanges multiple times without an explicit transaction. And when you do this, you run into a similar situation to what we just described, and the solution is again identical. You just have to create a transaction here, wrap all the changes that you want to be part of said transaction inside of the using block. In this case, we have an inline using statement, so we just have to make sure that we call commit async after we've done all the work. So now we've made this example safe. So let me just do a quick demo of the third example. The endpoint should be increase salaries bulk. So let me change this and send a request. And here we're going to open up a database transaction, do an execute update, which as you can see here will immediately update our employees table. Then we're going to update the company, call SaveChanges, which is going to use the EF Core change tracker and apply the respective update. And finally, when we commit this, everything gets persisted in the database. Now, if we take a look at the distributed trace, you can see that there's a bit more work happening here. So we've got our select statement here, fetching the company from the database. Then we've got our bulk update, which is the result of the call to execute update. But notice this line here. This is EF Core creating a save point within our transaction before doing its own work, which is updating the company's table and setting the last salary update. And lastly, before the transaction gets committed, EF Core releases the save point so that everything can be completed successfully. So just a recap of what we covered, EF Core has an implicit transaction, and as long as you're making your changes in memory and calling SaveChanges once, you're fine and you mostly don't have to think about this. If you've got nested calls with multiple calls to save changes, like we do here, make sure to wrap it all in a transaction. If you're using any of the SQL methods, these will not be part of the implicit transaction, and you have to create a transaction explicitly and make sure these are executed within the transaction. And the same goes for the ExecuteUpdate and ExecuteDelete methods. You also have to run them in an explicit transaction together with SaveChanges if you want everything to be transactional. And if you want to improve your knowledge about database indexing, I highly recommend taking a look at this video next. Make sure to click the like button if you enjoyed this video. Thanks a lot for watching, and until next time, stay awesome.